Hello, good morning, good afternoon to everyone joining us around the world. Welcome to Data and AI Live. First thing is this is a slightly new format for us. So if there's any technical glitches or anything goes wrong, just bear with us. And I guess that's all part of the fun. But thanks very much for joining us. I know there's people all around the world logging in. So hopefully this will be a valuable session for you. I'd like to introduce our guest, Catherine Breslin. Catherine is former Amazon Alexa AI leader. She's got a PhD in AI from Cambridge and currently is AI and machine learning consultant to various businesses. So she's about as bona fide, and she's a large language model expert as well, which I'm sure you'd be glad to know. So she's about a bona fide AI leader as you can get. And today, as you know, we'll be talking about large language models and how you might start using them in your business. So welcome, Catherine. Thanks very much for joining us.
Thanks, Jeremy. It's nice to be here.
Great. We've got a lot to cover. So we've got 45 minutes to set the session out for everyone. We're going to cover, we're going to start by talking about how certain large language models are trained. We're then going to move on to use cases for large language models and how you can define some of them. Towards the end, we're going to start talking about build versus buy and that debate, which I know a lot of people are interested in. We'll then move on to Q&A, so please ask your questions in the comments because we'll try and answer all of those if we can, time permitting. And we'll finish with Catherine's top tip as well. If you're a business or organization who's looking to start using LLMs, the top tip, the number one thing you should, or number one action you should take to start with in this endeavor. Just one thing before we start, I'm interested in understanding who, everyone joining us, who is currently using large language models in their organization. So if you want to put, as well as questions, if you want to put in the comments yes or no, it'd be interesting just to take a straw poll as to who is currently using large language models in their business. But I want to get going because we've got a lot to cover in 45 minutes, but we'll try and do it as best we can. The first thing I wanted to just cover quickly, Catherine, because we were talking about it off air, was how large language models are trained, and not how specifically, but what data they are trained on, because this was something that you talked to me about and I found hugely interesting. I think a lot of people viewing might find interesting as well. So, yeah, I was wondering if you could on that for us.
Yeah, happy to get started with. So language models, I think it's worth thinking about language model first. We ignore the large part to start with. So a language model is a type of AI model or a type of machine learning model. And these are sort of computer models which we learn from data. So we learn how the patterns of language work from text, and we can use a model which can sort of understand those patterns of text and reproduce them. And the way a language model works usually is you give the language model some text and it tries to complete it like a sort of smart autocorrect, essentially, like a much more intelligent autocorrect than the ones that we had a long time ago. So a language model you could think about as sort of a black box algorithm, which is going to take some text and then start to predict what the next words are from that bit of text. But what is really interesting, I think, is how the large bit plays into this and how that's sort of completely changed how we look and think about AI at the moment. So the large part, I think, has two aspects to it. So the first is in the sheer size of these models, like the amount of disk space that they take up. And the second bit of the large is what we were talking about before, is about the data that these are trained on. And so they are trained on large amounts of data, which usually has been taken from the web. So a lot of the companies that release these language models, so there's ChatGPT is obviously an example that lots of people know about. And just today, I think Anthropic announced Claude 3, their latest version, their latest update of Claude. A couple of weeks ago, Google announced Gemini, their version, and Meta have an open source language model that they call Llama. So a lot of the big tech companies have built their own language models, and they are more or less open about this amount of large data that they train on. And so we have to make some guesses about what the sort of data they're trained on is. But there are some things that we can work out from what's been published. So one of the things I like to think about is the size of the training data. And there's a particular data set that exists on the web called the pile. Now, Jeremy, how long does it take you to read a book, for example?
A long time.
A long time.
Yeah.
I'm going to say a few hours, maybe, to read.
I'm a sort of half a chapter get bored kind of chap, but so yeah, it can take me a long time, but I'd maybe a month if I'm going well.
A month. Okay. And so there is a data set that exists on the web called the pile. And part of that data set is a smaller data set, which consists of 200,000 books. Now, if it takes you a month to get through one book, presumably you've got other things in the way as well that are going to stop you reading. You know, it's going to take you can't get through 200,000 books in your lifetime. Even if you spent all your time reading, I don't think you would get 200,000 books when you're reading. And this set of books that exist on the internet, this 200,000 books, makes up about 12% of this data set called the pile. So it's quite a small proportion of it. And you can think just how much other text goes into that. And then what we do know is that this data set called the pile, if we compare it to the amount of data that Llama was trained on, Meta's language model, we know that it again is about 12% of that. So our 200,000 books make up about 1 or 2% of the training data of one of these large language models, roughly. So one book is such a tiny, tiny percentage of the training data. So that gives you a sense of the scale and what we really mean when we talk about large language models. They really are trained on huge amounts of data which have been taken from the web.
And to what extent are the big tech firms open about, I mean, we know about the pile, you just explained that to us, and the extent of data that's trained on. And I think OpenAI's training set is called Common. There's a similar name, Common Crawl. So it's a similar thing to the pile. To what extent, though, are they completely transparent about what goes into those huge data sets or not?
No, they're not. It depends on the company, and there are some companies have a policy of being more open about their training than other companies. But I think we're making educated guesses about the sorts of data that these models are trained on when they make their way into the products that we're using.
Yeah, got you. Okay. Well, thanks for that. Yeah, it's a point of interest which I found fascinating. Let's jump ahead though to the next topic we were going to cover, which is use cases for large language models and large language models out of the box. So I guess we're going to come on and talk about build versus buy later, but specific to this, we're kind of the assumption here is companies that are going to be using models out of the box. Is that fair?
Yeah, so I think I think about three kinds of companies really when I think about this. So you've got your big tech companies and your well-funded startups that are building these models, the ones that people are going to use. And then you have the companies that are at the other end of that spectrum that are simply just using what is provided by the big tech companies. And then there's a group of companies in the middle, the ones who are maybe more building their own technology and building on top of what's out there. So I think there's these three different categories that we can think of that companies fall into.
And we're not expecting anyone from Meta, OpenAI, or Anthropic to be on this webinar. If they are, that's great. Although maybe they're struggling if they are. So we're not expecting. We are expecting most people on this webinar to be from the second couple of categories. So either people buying models completely out of the box or building on top of them. So for those type of businesses or type of organizations, can you, I guess, talk about the typical kind of use cases that you're seeing from out of the box, or that you've seen to be valuable?
Yeah, so one thing that is really interesting about large language models is that they can do a lot of things, because by virtue of seeing lots of the internet, there's lots of things they sort of are actually capable of doing at quite a high level. And that makes them really interesting, because it's taken, when was ChatGPT launched? About a year and a half ago. It's taken that long to sort of figure out what these models are good at, what they're not good at, what we can and can't use them for. And so they don't come with an instruction pack of like, these are the things that we have trained it to do, and these are the things you can expect. And people are discovering new things all the time, and niche use cases and things that can work for their business. But obviously these models are dealing with text data, and so their primary use is in dealing with text. So there's a lot of things that people are trying to use them for and have found some success with. So for example, helping you to write. So if you want to write emails or documents or even computer code, they're actually reasonably good at writing some computer code. So you can use these to help you get started with those sort of tasks. And people will complain, you know, the sort of text that they output is quite generic and obviously from these models, but they can be a great sort of brainstorming back and forth, a great starting point to go from. They can also be used for things like summarizing documents and questions, so asking questions of a document. So if you're a company that has large amounts of text data, they might help you to be able to navigate that text data a bit more effectively, to be able to summarize your documents, ask questions, like I said, or even, you know, transcribe your meeting and summarize your meeting notes, those sorts of sort of admin tasks. And then one other that I think is really interesting is that these models have a sort of inbuilt capability, or they have some capability in translating between languages, because obviously it's not just English text that has gone into training them. There's other language text too, and so they are able to do some translation, and that can be really helpful, especially if you're an international business and you're looking at translating your text between different languages or facilitating communication between people who speak different languages. These are just some of the ways that people are using them, and I'm sure we're going to see lots more come out of the box as people discover how to use these better.
Yeah. So if you're a CEO or a business leader and you're kind of coming to this fresh, then what are the things? I mean, are you saying the things that you should look at in your business or start thinking about where large language models out of the box can have an impact are typically admin heavy processes? Is that how you should angle your thinking, or are there any other angles?
I think that's one of the things, the sort of admin processes, and that helping people to write, helping people to search. These are all sort of processes that business use. Helping people to work perhaps a little bit more efficiently, those they can help. And I do know that a lot of companies do have large stores of text data. So maybe it's not to do with admin, but in terms of organizing and extracting information from those as well.
Yeah. Well, that's the next thing I was going to talk about was the data, because I'd imagine the questions a lot of organizations are going to have are around, well, do we have enough data? What kind of data should we use? Yeah. Just before I do that, we've had a question come in from Harpreet. So thanks for that, Harpreet. I don't know if you want to answer that question.
What's the best way to validate the results of a large language model?
Yeah.
That's the question.
Do you want to do that now or wait till the end?
That is a super interesting question, and actually is receiving quite a lot of attention at the moment. So what we have in the machine learning world is we usually create some sort of evaluation scheme where we have a set of examples. We know what the answer should be. So for translation, you can have an example sort of English text and maybe it's your German text, and you know what the translation ought to be. Translation, though, as you might know, there's no one-to-one correspondence. So how do you judge whether it's accurate or not? So some of these things you can automatically judge whether they work well. So if you're looking for a snippet of information in a document that answers a specific question, maybe that's something you can automatically score. If you're translating, you might want people to judge the quality of the translation. And so I think these are the two main ways we use at the moment, is to create a data set where we can automatically score how well it does because we know what the answer should be, and a data set where we kind of know what the answer should be and we want a person to judge whether it's a good answer or not. The first one is obviously cheaper because the automated scoring you can do again and again and again. The second one, you need people in the loop to be able to do it. But there are lots of things we're asking language models to do where I think it's really difficult even to do that human level of scoring. So if you are asking a language model to write an email or to write a story or to do some sort of critical piece of thinking or piece of writing, those, I think it's incredibly difficult for a person to judge how good or not they are. And we are still trying to figure out how to go about judging those. But the way that large tech companies do this is they have a huge bank of tests which they run, and some of them are maths tests, some of them might be legal tests, some of them might be English tests, and then they score against all of those.
Yeah, got it. So I mean, long story short, you've kind of there's an automated way of validating and then a human way of doing it, and it's context specific.
Yeah, exactly.
Yeah. Okay, great. Thanks, Catherine. We've had a couple of other questions come in from Ashish and Jesus. We're going to leave those till the end just because they're really good questions and they need a really good answer. So yeah, we'll leave them to the end. But thanks for those questions and keep them coming in. So going back to models out of the box, let's talk about data. So if you're a company, you've defined a use case for it. What do you need to think about in terms of data? How much data do you need? What does the quality of that data need to be? Can you speak to that?
Yeah, so the amount of data is one of those questions that everybody would love a specific answer to, but it's a really difficult one to answer out of the box. So you don't just need quantity of data, but you also need diversity of data. So machine learning models, they learn the patterns of language in the data they're trained on. So if you are only training a model on, for example, financial earnings calls, and then you want to do something which is related to I don't know, medical use cases, your model trained on financial earnings calls is not going to work well on that medical data task. And so you need enough diversity in your training data set to be able to capture all of the things you want to do as well. You also need, like we were talking about testing models, you need enough data to be able to test properly. And you also need enough data to be able to build the sort of, these are large models, we're talking about the sheer amount of training data that some of them are built on. So there's all sorts of different aspects, and I think it depends a lot on your starting point and where you want to get to as well as to what exactly the right answer to that is.
Yeah.
The other point I think that people throw into this is, there is sort of a backlash and a pushback against some of the data that these models have been trained on. And I know that there are lawsuits going on at the moment when it concerns copyright. And so that the origin and the provenance of that data also is something to think about, and whether you have the right permissions and you're able to train on that.
Yeah, absolutely. And let's segue onto that just quickly, actually, if I may, because we're going to come on to build versus buy in a couple of minutes. But I think one of the questions you're seeing a lot at the moment is, and there's a big question come in from Arnav on this topic, and we'll cover that specifically later, Arnav. But in terms of responsibility, ethics, security around this, what to come if you're buying models out of the box and looking to feed it with your own data for specific use cases, and we've only got 2 minutes to cover this, which is a massive topic, but what are the things that leaders should be thinking about just in terms of the security and ethics around that when they do it?
Yeah, so like you said, this is a huge question. There are entire, PhD theses and master's courses on this question.
We'll do another episode on that.
So this is just a tiny little fragment, spotlight on some of these issues. And I see the question about hallucinations, which is one of the issues that people are concerned about. And there really is no way to restrict or even identify hallucinations of language models. It is just one of the characteristics of the way that they are built right now. And I think there is somebody who also mentioned, hallucination is not quite the right word, because everything a language model does is somehow hallucinated. And sometimes it just happens to be right or useful. But there are other concerns that companies are thinking about as well. And some of them are to do with bias and how well. So these models, like I say, they are trained on large amounts of data from the internet, and they reflect and somehow embed some of those biases that we as a society have. And so you see news stories about these models exhibiting sort of gender bias and racial bias and other kinds of bias as well in their outputs, which obviously we as people can spot and avoid, but because they exist on the internet, these models, sort of do reproduce them in a way which is just doesn't let you have any control over that. And there are also questions, I think, of accountability. And if you are using these sorts of tools, and especially if you're buying from someone else, who has accountability for when and when it doesn't go wrong? And I think that's a point that companies have to wrestle with as well, depending on the risks associated with what you're using them for. You do have to consider what happens if they go wrong, what happens if they are biased, and where that accountability lies. There are so many other issues. I think people think about misuse of them, working within their limitations, understanding their strengths and how they work in order to use them most effectively, and about some of their more regular sort of data security and privacy issues as well. If you are working on a sensitive topic and you are transferring your sensitive data over the web to another company to process using their language models, how does that work with your obligations to your customers and your legal obligations too?
Yeah. And on that, I guess one thing, and this might sound like a really stupid question, but are there things that companies, organizations should be aware of data that they have that they shouldn't be putting into these models?
I don't think there's any one specific thing that companies should do, but they should be thinking very thoughtfully and intentionally about the data that they're using, where it's coming from, what permissions and consents they have. And something like GDPR in the EU does cover some of that sort of data consent and those sorts of issues as well. So there's definitely regulatory frameworks that people have, but also you want to be acting in the best interest of your customers.
Yeah. Okay. I feel we could talk about this for ages, and it's probably worth another episode. But I guess as a top level takeaway, then it's organisations just need to be aware that the output can be biased, they can go wrong, and just be aware of that and measures in place.
Yeah.
Let's move on, because we've got for time to build versus buy, which is a huge topic of debate, and well, not debate, but I guess conversation in this area. And I know we've chatted about this before, and I suspect, well, I know your answer is there is no one answer. It's going to be context specific. But yeah, tell us a bit about the context of where you might want to buy, where you might want to build, and your thoughts on this topic.
Yeah, so we talked about these sort of three categories of company, and the second two that we're really focused on are, I think, the companies who are buying in this technology versus the companies who are trying to build some of their own. And I think those two types of company tend to have different characteristics. So if you are a company which is building your own technology, you're probably not building it from scratch now. You're probably building on top of some of the open source models that are out there, or some of the open source data sets that are out there. But what you need in order to do that is a good, strong engineering and data team to have the skills to take what's out there and build what you need on top of it. And that comes at a cost. I think it can be more expensive in order to be able to have the right skills in your company to effectively be able to build this technology. There's also, I think, a speed to market constraint to think about. So if you are building technology as a company versus buying it is probably going to get you to market quicker, because somebody else is building it for you. You can just buy and use it and develop your product. If you're building that technology yourself, it's probably going to take longer. But that is assuming that there is not much of an integration effort if you're buying. So sometimes you might buy something which is not quite what you want, and you have to put a lot of work around it to make it work for what you're doing. So there's a balance there between speed to market, how much integration effort there is, and the sort of cost that you have as well. And then I would also say, in order to be a sort of data-led and engineering organization, you have to look at the maturity of those skills within your organization, who you have, who has those skills, and whether your organization is capable of building the technology.
Yeah, so it's a multifaceted equation. really, and you're looking at things like your appetite for risk, budget available, skills, engineering skills you've got in the business versus who you could hire and your budget for that.
Absolutely.
And that's going to be context specific, depending
And
on
you
your
know, because of what you do, like hiring people is tough in this market, especially those sort of senior and experienced data and engineering leaders that you might need.
Yeah, but at the same time, and I don't know if you agree with this, but I kind of think that's, if you haven't got that talent internally, I still think, and I'm still seeing that organizations who haven't are able to buy out of the box and create value quite quickly and at relatively low cost if they are strategic about the use case.
And absolutely, I think one of the things that has happened over the past few years with machine learning and AI tools is they've become so much easier to use. There's much more choice available. You can integrate them very much more easily than you could. About 5 years ago, you probably needed a team of engineers to even run one of these models. And now you can just send your data off to ChatGPT via the web and get something back. So it becomes so much easier to integrate and use in an organization.
Yeah, absolutely. And I think that's, I don't know if you'd agree, but I think this is one of the sort of the differences between, let's say, the AI hype cycle and maybe the data science hype cycle of a decade ago, in that I think organizations on specific strategic use cases can start creating quite value quite quickly and at relatively low cost. Whereas perhaps with the data science revolution, it was a bit more time consuming and a bit more expensive. I mean, one example of that I've seen is a large professional services firm I was speaking to a few weeks ago bought out of the box and created a tool to that would allow clients to get information on very specific topics very quickly, but at a very low cost. So essentially, they were selling it as a kind of introduction to their business at a very low cost. So they were gaining clients and maybe introductions to organizations that they otherwise wouldn't do, and then that was leading on to much more bigger pieces and more expensive bits of work in the future. So it's just sort of one interesting and I think invaluable use case I'd seen from an organization that did, and they didn't have internally the big engineering team to start building the technology themselves. Any in terms of the build versus buy, any other specifics on that you'd want to touch on at this point that we haven't covered?
I think we touched on sort of speed to market, and we didn't really talk about hiring. So I think that's an interesting point in the sort of skills you might need, because we talk a lot about, the machine learning engineers, machine learning scientists, and how they can work. And a lot of organizations are used to working with software engineers and perhaps also with data scientists now. We're sort of adding into the mix another type of skill that engineers are using, and that is to do sort of the ML engineers who are capable of working with and integrating some of these tools, and then the machine learning scientists who are the ones building and tuning and tweaking and experimenting with those models. So those are the sorts of skills that you want to bring into your company as well, I think are really important in making that decision. And it's a trade-off between, how much is available and how easy that is to use, which is getting easier all the time, and how quick you want to move and whether what you need is available or not.
And as you inferred, and we've got other episodes coming up on kind of workforce planning around this area, but as you inferred, those type of talents can be very expensive, often difficult to find or prize away from other firms. So I guess it's another thing to think about in the equation of build versus buy. Okay, thanks for that, Catherine. I think should we move on to questions, because we seem to have quite a few questions that have come in. So let's try and take them in order, shall we? Here we go. Oh, we've done. So what's the best? Here's a question from Ashish. Thanks for your question, Ashish. What kind of large language model use cases have you seen in the retail industry?
So this is one industry I haven't worked very closely with, but I do know that customer service is a very big part of retail industry. And so when it comes to customer service, that is an obvious place for voice and language technology to be used in different ways. So that's one place I would say. And I think another place that is really interesting that's coming together now is not, we've just been talking about language models, but if you have used GPT-4 or some of these other models, you know, they deal with images as well. And so I think we're starting to see these multimodal models which deal with text and image. And I can see a lot of use cases in retail for sort of, there's a lot of photography, there's a lot of images, there's a lot of creating content in these industries for marketing purposes as well. So I think there's some really interesting places for image technology to come into the mix as well.
Yeah. What I've seen in the retail space in terms of text is large language models automating descriptions of items based on your own, or based on the own personal data that they've got about you. So, I mean, for example, if me and Catherine are both buying a kettle, maybe the description that she gets might be different to the description I get based on what they know about us both. Got a question from Jesus or Jesus, I don't know, hope I've got it right. You talked about the size of the training data set. What about the size of the actual trained model? As an edge AI developer, I'm considering running LLMs on small embedded devices with limited resources.
So this is something a lot of people are thinking about, because the models that come out of the big tech companies are large. Some of them, like Gemini and ChatGPT, are sort of behind APIs, so you can't download and build on them. You can only use them by sending traffic back and forth. But there are some that you can download and use. So there's, I mentioned Meta's version of Llama. Google have released recently a model based on Gemini, which is called Gemma. Mistral in France have released a model called Mixtral. And these come in varying sizes. So language models tend to be measured in the number of parameters that they have. And so these might vary from sort of 7 billion parameters up to 140 billion parameters. And if you want to load these onto your machine and use them, they require like a huge amount of energy. I couldn't load it on my laptop, some of these models, and use them. And so this is a problem for everybody who wants to use them. So people are spending effort in figuring out what they can do about this. So there's two approaches that I think people are doing at the moment. One is about shrinking the size of the language models, so building smaller language models, fewer parameters on large data sets still, and finding ways to make those as effective and as accomplished as the bigger models. So depending on what you want to do, some of those smaller language models might be perfectly suited for your use case, and you can run the smaller versions of the models. I think developers have read somewhere that anything under about 10 billion parameters is considered a small language model at the moment. Even those are quite hefty, but there are these options out there. People are thinking about how to build them. And the other thing that, sorry, go ahead, Jeremy.
No, I was just going to say, so should you, if you're considering using large language models, should you look at the size of your compute versus the parameters of the different models? Is that something you should consider?
So I personally would start with the use case and what was a useful model, and then figure out what compute I needed to be able to make that work and do the costings from there. Unless you are very constrained by the compute, which maybe this question is about because it's about edge devices. But in general, you can more effectively buy the compute you need to run the model you need than to shrink a model down to your compute. I was going to say the other thing that feeds into this is if you're an engineer, you will know about quantization. So quantization is a way of shrinking the size of a model. So we can think about this. Machine learning models have lots of parameters in. I mentioned, 2 billion parameters. And each of those parameters is a number. And that number has maybe like 10 decimal places. So if you store 10 decimal places of a number, obviously that's going to take up a lot of storage. But if you shrink it down to, say, 1 or 2 decimal places, you can shrink the size of that model. And so you're effectively cutting the number of decimal places that a parameter is. Now, the mathematicians and the computer scientists will shoot me for that explanation, because that's not exactly how computers represent numbers, but it is about storing numbers with less precision and creating a smaller model as a result of that. So that is another option when you're talking about an edge device with limited resources, is look at what the quantization approaches out there are.
Great. Thanks, Catherine. Thanks for your question, Jesus. We did this question earlier from Arnav. Is there anything you wanted to add on that, Catherine?
Just only to say that if anyone has ideas, I mean, there's a whole industry waiting for answers to this question.
Yeah, it could be a very valuable solution, Arnav, if you can come up with it to that one. Parissa asks, what kind of applications can we build on top of LLMs like ChatGPT? Thanks, Parissa. I assume the answer is all sorts of applications. But
yeah, I think we're still figuring that out. Like I said, we're still trying to figure out all the use cases. But what I see is companies who are building specific applications for specific verticals and specific domains. So they're taking the language model, say from OpenAI or Anthropic or one of these companies, adding in their own knowledge of a particular domain, their own business knowledge, their own tools, and building a product which expands the language model to do specific things in a domain, in a vertical.
Yeah, great. John Savage asks, given the prevalence of hallucinations within LLMs, seems like having a human in the loop is required. How can companies embed large language models in fully autonomous systems?
So you're right. There is this prevalence of hallucinations that exists right now, and models just being outright wrong. And so I think the thing here is to think about the level of risk and the consequences if something is wrong. So if you are in your company, if you are having regular project meetings about something, and you're using a language model to summarize those meetings and it is wrong at times, that might be low risk because you have a lot of institutional knowledge and the way you use that is not problematic if it's wrong. But if you're doing the same thing in a medical setting, where those summaries of transcriptions of medical meetings are passed down the line to other healthcare professionals and get used, and there are mistakes in them, then the consequences are much worse. So I think a lot of companies that have either want to produce high quality output or are working in a domain where the consequences are bad, then if something is wrong, then they really do need to think about human in the loop and ways to mitigate those results. And some of those companies that have lower risk applications and lower risk use cases are able to build automated systems around language models. But there is no real way to get around the fact at the moment that AI machine learning models, they are predictions and they are often wrong in ways that somebody came to me the other day and they're like, my model has done this thing and I can see it's wrong. It's just obviously wrong. How can I make the model say that this is wrong? Sometimes machine learning models make mistakes that just look really weird, look obviously wrong.
Well, we all make mistakes, don't we? But I guess the answer is it's understanding your risk profile, isn't it? And kind of putting human measures in place accordingly. We've got a question from a non-LinkedIn user. Could we use Copilot to create our own LLM?
Could we use Copilot to create? So Copilot is a term which I'm hearing used in different ways now. So Copilot sometimes is to do with writing code, and sometimes it's to do with being an assistant and generating data. So in terms of writing code, potentially, I mean, these things are getting better at writing code, but yes, I think you're in the situation where you need a human in the loop to put it all together and make sure it's working. And then in terms of using a model, so this is an interesting thing that people are doing, is using generative AI models to generate data to train other models from. So there's this generating synthetic data, as we call it, or data augmentation. Now, whether this, there's thoughts about, if the internet becomes just AI generated and then models learn from it, and then, this cycle continues, whether everything will just collapse and the models will not be effective anymore. But we're not going quite down that far. But can you use a model to generate data to train another model? And I've seen very good examples of this being done. And some of those small language models that I talked about from Microsoft have a couple of them where they have used these models to generate the training data in a very specific domain to build a language model. So that's an interesting way to use some of these models in the building of newer versions of the models.
Yeah, absolutely. If anyone wants to hire a very expensive engineer, hire one that's got experience of creating synthetic data. We've got a question from Eddie Short. Thanks, Eddie. NVIDIA have cornered the market for AI processing. Yeah, this seems more on the processing side, but let's take it anyway. And NVIDIA are charging ridiculous prices and long lead times. Who do you see competing with them to bring prices to a more affordable level?
So you're right, NVIDIA really have got the market cornered in GPU power right now. And some of the best GPUs, the ones that people want to use, are NVIDIA GPUs. There are other options. And I think one of the things that's happened as NVIDIA have built out their GPUs is that the code, the libraries work with NVIDIA GPUs. And so if you want to use another company's GPU, there might be some migration work to make your code work on a different GPU. So that's another sort of way that this gets embedded. Whether there's anyone else, I mean, there are people building GPUs. There are several startups I know who are building hardware for AI and other companies, but none of them quite have the market reach of NVIDIA right now.
Thanks, Catherine. Thanks for the question. Eddie, we're going to take one more question because we are running out of time. So apologies anyone that's asked a question that we haven't got round to answering. Patrick asks, for those in analytics, translator or business consulting roles, what advice do you recommend for deep versus wide technical knowledge?
Ooh, so that's an interesting one. I find myself often in roles talking with companies, talking with non-experts, AI experts, and AI experts. And so that translation does require a certain depth of knowledge to be able to understand what the different sides are talking about. So I think having a deep knowledge in one place is useful, but also the ability to be able to talk appropriately with technical experts, to be able to ask the right questions and have them explain to you can help. So you don't necessarily need to know all of the deep technical knowledge, as long as you can, when you need to, you can talk the same language as the engineers and talk the same language as the data scientists in order to be able to understand what they're doing and help you translate it for the other people. So it's a little bit about the depth of knowledge you have, and a little bit about, I think, your ability to just, ask the right questions of both sides, not just the technical side, but also asking the right business questions of the CEO and the executive team to be able to effectively do that translation.
Great, thanks, Catherine. I told a lie before. We're going to take two more questions. If anyone's got to log off, please do so. But we're going to take two more just because they're interesting ones. Harpreet asks, any recommended tools to get the workforce quickly trained and start experimenting?
Quickly trained. So these models, it's quite a new way of doing things, this large language model, and start experimenting. I think you just have to go for it. I don't think there's a lot of tools and training out there right now. And I think the best education is really just to sit down and play and see what happens, and try some of your use cases, try some of your depending on the sensitivity and whether you want to upload your documents to these services or create examples, create fake examples of your data that you can use, so that you can just sit down and play and then talk within your company. So, you might discover different things, you might have different ideas when you talk to other people who are doing these. So I think that's the best way. I don't think there are particular tools that I have seen that maybe other people have and have things to recommend. But for me, I think the best way to get started is just to sit down and have a go.
Great. Thanks, Catherine. And final question, which came in before the show started, so I can't bring it up on the screen, but someone was asking about deploying LLMs on-prem versus on the cloud in the context of security and risk. So wondering if you could talk about that.
Yeah, so there are definitely companies who have obligations to their customers about where they can and can't process data, or they just have a certain risk profile and they don't want to risk sending their data out to a third party, or they feel it's not the right thing to do. So there's definitely, I think, use cases for running these things on-prem or on your own servers. And then I think this relates to the discussion we had a little earlier about the question about running on edge devices. It's a similar-ish discussion because probably you want to find the right computing power to run these, but also see if there are smaller models or maybe these quantized models I talked about that you could run locally with less effort. And then I think depending on what your product is and what your service is, you might then need sort of engineering work around that to support running this. So if you've got millions of customers and they're all sending requests to your language model at the same time, you need some engineering in there to spread out the load and to make sure that all those requests are getting answered in the right time and there's no problems with that inbound set of requests. Whereas if your model's only being used by a handful of people, maybe you don't have such an engineering effort and it doesn't need to be up all the time. So there's the engineering effort that you have of keeping any service up and running that you have to think about, and then the sorts of models that you will run on your own computer, and whether you want to run a small model, run a quantized model, train your own sort of fine-tuned specific model that's better for your task, and those sorts of things.
Yeah, fantastic. We've got lots more questions. We're not going to be able to answer them, I'm afraid, so apologies about that, because we want to let people go and have their lunch. But we're just going to finish with, I guess, Catherine, if you're a CEO or you're a leader in an organization and you're considering using large language models, what is your top tip to give to those people in terms of maybe what's the first thing they should think about if they're considering going on this journey?
So I think this ties very nicely to Harpreet's question that we just talked about. And I think my answer to this is just experiment. Encourage your team members to experiment within parameters. So, tell them what is acceptable and isn't acceptable to upload from your company's data to these services, but just experiment with what's out there. See what they are and aren't capable of. See if they'll do the task that you want, that you're thinking of, or not, and where they go wrong. Because that's the best place to start. A lot of people are sort of afraid of jumping in and seeing what they can do. And I think learning is the only way, because these systems are maturing all the time. We are not really at the stage that they are embedded in our daily lives yet. And so there's a lot of learning to be done about them, which can only be got by trial and error.
Great. Well, I think that that message is a great way to finish. If you're thinking about it, just go for it and experiment and start learning. Thanks everyone for joining us today. Really appreciate it. We're going to be doing a lot more of these coming up on different topics. I think Catherine and I may be doing another one going into a bit more depth in some of these topics, because I know we've covered a lot in a short space of time here. So yeah, look out for messages and alerts on those. If you've got any more questions or are thinking of starting to use large language models and want to reach out to an expert, reach out to Catherine, because she's one of the best in the business. And yeah, we look forward to joining you again soon. Thanks very much.
Fantastic. Thanks very much. Thanks for hosting, Jeremy.
Bye-bye.